Hello and welcome you all to this lecture. Here we will be discussing another important tool to find particular integral, that is particular integral using inverse operator method. Inverse operator method. Say in the question, if a non-homogeneous equation, it is given to you and the method it is not mentioned, in that case directly you can apply this method, because out of variation parameter method of undetermined coefficient, and this inverse operator method, this inverse operator, the last one, it is quite simple. So that's why it is recommended that if the method it is not specified in the question, you can go with this inverse operator method. So what exactly this inverse operator method is, we'll learn now. So for that, see, if you have d, it is standing for d dx, means the derivative. D stands for derivative. So if I consider d, this operator, as the derivative operator, so immediately if I write d inverse, it represent integration. Okay, so d inverse, it represent integration. Suppose it is with respect to x, so integration with respect to x. Okay, d inverse. So wherever we have this 1 by d, that immediately represent integration. Okay, 1 by d square, that is double integration, 1 by d cube, triple integration. Okay, so on. So basically this is the inverse operator concept. So here, based on different type of question in the right hand side of our considered differential equation, will have the different formulas. Okay, so let me write one form. For example, let f of d y is equals to x. F of d y is equals to x. Okay, this function here, this capital X, it can be exponential function e power ax. This can be, suppose, sine ax or cos ax. This can be polynomial function or combination of sine exponential function or polynomial function, or it can be combination of different type of function. So so in that case, what will be the particular integral? So particular integral, it is given by 1 by f of d of capital X. That is particular integral. All right, now see here, general method of getting particular integral. One important result you should consider here, that is important result, general method to find particular integral. Okay, if x is a function of small x, if x is a function of small x, then the particular integral, it is given by 1 by d minus alpha of x. It is e power alpha x integral x into e power minus alpha x dx. So for that, if you just want to get the idea from where we are getting this formula, so for that you can note this one. You can note that let d minus alpha y is equals to capital X. This is our differential equation, considered differential equation, which is nothing but a linear differential equation of first order, and the standard form you can write here, dy dx, that is minus alpha y is equals to capital X. So here immediately you can see what is integrating factor. Integrating factor is e power minus alpha dx, that is e power minus alpha x. Now the solution, you know that y into e power minus alpha x, x multiplied with e power minus alpha x dx, and that is equivalent of writing y is equals to e power alpha x, here x into e power minus alpha x dx. And see what is y, see from here, if you want to write this y is nothing but 1 by d minus alpha of x, that is 1 by d minus alpha to x, that is equal with this quantity, which is nothing but particular integral. So this is particular integral general formula. Okay, this is the general formula, this is our general formula. Okay, all right. Now from this formula one can derive different type of results. Okay, so different type of results means if this x, this x it becomes e power x, what will be the situation, or it becomes sin ax, cos ax, polynomial or combination, so what will be the situation, those things we can discuss now. Okay, so first rule or first formula you can write, the previous one it was general formula, now we can have the subsequent particular cases. Okay, so when x is equals to this, x is equals to e power ax, when x is equals to e power ax, in that case particular integral it is given by 1 by f of d e power ax. So immediately the formula goes like this, 1 by f of a e power ax, provided f of a not equals to 0, this is not equals to 0. So if f of a it becomes 0, if f of a it becomes 0, so in that case what you need to do, multiply the upper term by x and differentiate this lower term by d. Okay, and put d is equals to a, that is f dash d, and in place of d you will put a, e power ax, provided f dash a not equals to 0. Similarly, see if suppose f dash a is 0, if f dash a it is 0, so in that case again the same thing you need to do, that is multiply that upper term by again x and differentiate this lower term with respect to d second time, and that is f double dash d, and in place of d you will put a, e power ax, like this, provided f double dash a not equals to 0, like this you will proceed. Okay, so basically the lower term you should get not equals to 0. So this is our formula. Okay, so you can note down this formula as well, that is particular integral when x is equals to e power ax, then this is your main formula. Okay, now we can move to our next slide. This method, it is very useful method, and you should practice questions. Now next slide. So we are taking the next question or next formula. In fact, we can write second formula. That is, if x is equals to, suppose if x is equals to sin ax or cos ax, so in that case the particular integral or yp, it is given by 1 by f of d square, say f of d sine ax. So basically f of d, this thing will be given in the question. Now your target will be to write f of d in terms of phi of d square. That means whatever the function it is given, will try to convert in terms of function of d square. Okay, through question it will get more clear understanding. Okay, so by that time you just write down, we will solve question, that time you will get more clear idea. Now see, this is nothing but f of d. You can write this one in terms of some function of d square, and once you have this one, that is equivalent of writing 1 by phi of d square sine ax. The same thing goes for cos as well. So now here this is equivalent to phi of minus a square sine ax, again provided phi of minus a square that is not equal to 0. Okay, so phi of minus a square not equals to 0. If it is 0, again the same treatment, that means multiply that upper term by x and differentiate the lower term, that is f of d, with respect to d, and then again in place of d square you will put minus a square. This is the idea. Okay, so this is for sine ax. Next formula you can write third formula, that is if x is equals to, suppose it is a polynomial function x power m, if it is x power m, so in that case the particular integral, that is 1 by f of d, suppose x power m you have. So this f of d, you need to represent this f of d in terms of either 1 plus phi of d whole power n, or 1 minus phi of d whole power n, like this. Okay, either of these two forms. Suppose I am taking this form. Okay, so in that case 1 by 1 plus phi of d whole power n x power m, this thing you need to apply. Now see, once you have this one, so immediately what you can write, 1 plus phi of d whole power minus n x power m, this thing you can write. Now here we can apply binomial theorem. For that few standard result you need to know, we'll consider those results when we deal question related to this form. Okay, so for the time being you can just write down these formulas. So here need to use standard formulas, will provide those formulas. Okay, will provide those formulas. Now another form that is given by this form, suppose it is combination x is equals to, suppose x is equals to e power ax into v. This v can be any function of x. This v, it can be either polynomial function, it can be trigonometric function, whatever. Okay, this v is any function of x. So immediately the particular integral, it goes like this: 1 by f of d, it was there, e power ax into v. Now the formula says that e power ax, you can take it out and write this f of d plus a, and it acts on v. Okay, this is the formula. All right, now see, these are standard formulas, and you can note down these formulas for the time being. And now we are going to solve few questions, okay, so that you can get clear idea of this formula and how we can apply these formulas. Let me recall those formulas. This is our first formula. This is the general formula that we considered, And from this formula, if anyone interested, you can derive these subsequent particular formulas. Okay, this is our first formula. If exponential function is there in the right hand side, now this is our second formula. So this is our second formula. You can see this one. This is our third formula, this one, and next this is our fourth case. Okay, so now we'll continue with few questions. So suppose, write down this question: solve d square minus 3d plus 2y is equal with e power 3x. Okay, so solution. First step, writing the auxiliary equation. Auxiliary equation, it is given by, wherever you have d square, you can put d, we can put m. So m square minus 3m plus 2 is equals to 0. So immediately it will be m minus 2, m minus 1, that is 0. From here you will get m is equals to 1 and 2. So CF, that is YC, you will get as e power x, C1 e power x plus C2 e power 2x. Okay, now YP you can write 1 by d square minus 3d plus 2 e power 3x. Now what was our first formula? This is nothing but f of d. So what you need to do? 1 by f of d e power ax. This was our formula, and you need to have f of a e power ax provided f of a not equals to 0. This was our formula. Okay, now see, as per this formula, you just need to check this term by putting d equals to 3, whether it is 0 or not. If non-zero, immediately you will get the answer. So in the rough you should check this thing. Okay, that is d square means 3 square minus 3 into 3 plus 2, that is 2, which is not equals to 0. So immediately you can put this value, that is 1 by 2 e power 3x. This will be yp. See how easily we can derive this particular integral if you know this formula. Okay, so the general solution, it is given by y is equals to c1 e power x plus c2 e power 2x plus 1 by 2 e power 3x. This will be the general solution. See how easily we can derive. Now next question you can take. Next question, solve here d square plus 4d plus 4y is equal with 2 sine hyperbolic 2x. Sine hyperbolic 2x. So solution. So first step is what? Writing the auxiliary equation. Auxiliary equation, m square plus 4m plus 4 is equals to 0. So from here what you will get? M plus 2 square is equals to 0. So from here m is equals to minus 2 comma minus 2. Okay, so yc will be c1 plus c2 x e power minus 2x. Okay, now yp, what is yp? 1 by d square plus 4d plus 4. Here what you have? 2 sine hyperbolic 2x. Now see, sine hyperbolic 2x, that is nothing but e power 2x minus e power minus 2x by 2. This formula, you should know. This is one standard formula of sine hyperbolic x. You should know this formula. Now if you put this formula, immediately it becomes 1 by d square plus 4d plus 4, that is e power 2x minus e power minus 2x. See, you need to remember these formulas because hyperbolic function already you had the idea. So these formulas are required. Now see, next step, this d square plus 4d plus 4, this can be written as d plus 2 whole square, just for simplification of this solution, minus 1 by d plus 2 square e power minus 2x. Now see, as per that previous formula, what you have in this first term, d plus 2 whole square e power 2x. So in place of d, if you put 2, obviously you are getting non-zero term here. So 1 by 2 plus 2 square e power 2x. Whereas in this next term, if you put d equals to minus 2, immediately you are getting 0. So in that case, what you need to do, see here, the upper term, you need to multiply this upper term by, observe this treatment carefully. This is the application of the same formula with if f dash equals to 0, then what you need to do. So here multiply this upper term by x and differentiate this lower term by d first time. Okay, so what you are getting, 2 into d plus 2. So 2 into d plus 2 e power minus 2x. As per this setup, here again in place of d you need to put minus 2. So immediately, if this lower term it is 0, obviously here you are getting 0. So again the same treatment you need to do. So here the first term as it is, so 416 e power 2x minus, here see again the same treatment, that is x square divided by 2 into differentiate this term with respect to d, that is you are getting 1. So x square by 2 e power minus 2x. There is nothing to put, okay, here in the lower term. So this is the final yp. So the general solution, it is y is equals to c1 plus c2x e power minus 2x plus 1 by 16 e power 2x minus x square by 2 e power minus 2x. This is going to be the final solution. Okay, this is how we solve the question where we have this type of situation. Okay, so again let me give you the idea from previous slide. See, this is the application of this situation, okay, where the lower term it was 0 and the subsequent step it is multiplied by x and differentiate with respect to d and put d equals to a. Okay, so this is the application of our first case. Now we'll move to the next slide where we'll see the application where the sine or cos function they are involved. Now take the next question. Solve one of the very simple question I am giving, that is, suppose y double dash plus y is equals to sine x. Solution. So just like the previous step, here the equation, it is d square plus 1 y is equals to sine x. This is given. So auxiliary equation, this is nothing but auxiliary equation, m square plus 1 is equals to 0. That is equal with m is equals to plus minus I. Okay, plus minus I. So from here yc you can write c1 cos x plus c2 sin x. Now yp, see yp, how easily we can find yp, 1 by d square plus 1 sin x. Now see here sin ax, so a value it is 1. just go back to the previous slide and see the formula. See, here this function you need to convert in terms of phi of d. Okay, that means basically function of d square, and in place of d square you need to put minus a square, provided this term, lower term, it is not equals to 0. So here, come back here, what you have, see. So here if you put d square, here a is equals to 1. So if you put d square equals to minus a square, that is minus 1 plus 1. So you are getting 0. So you are getting 0. So what you need to do? Again the same treatment. That means multiply here by x, and here what you have, 2d sine x. Correct? Sine x. So from here what you have, x by 2 1 by d sine x. Now here see, either you can convert this d in terms of d square, that means multiplying this numerator and denominator by d. This is one way. Another way is what, you know that 1 by d it is nothing but integration with respect to x. So here immediately you can perform this calculation, that is sin x dx. So what you have, integration of sin x means x by 2 cos x. That is general solution given by y is equals to, already you got it, see, c1 cos x plus c2 sin x minus x by 2 cos x. Okay, this is, say here, this is one technique, to solve once you have this 1 by d term. Okay, another technique is what, see, another technique, what you have, x by d, here you can do d by d square, that means multiplying this numerator and denominator by d. So immediately what you have here, sin x. So in the next step, x by 2, in place of this d square, what you have, that previous understanding says that in place of d square you need to put minus a square. So immediately minus a square means minus 1 square, that is minus 1 sin x. Alright, so immediately in the next step, x by 2 d of sin x. D of sin x means derivative of sin x, that is nothing but cos x. So x by 2 cos x. See, both the method giving you the same, exactly same answer. Okay, exactly same answer you are getting by both the methods. That means either you apply integration or you just go with the usual method, you are getting same answer. So either of this method you can follow when you have 1 by d for sine or cos function. Now next, another question I can take from this sine or cos scenario. So I will go with this question, that is, next question you can write. You can write down next question. Next question is solve d square minus 5d plus 6y is equals to sine 3x. So here solution, yc is going to be c1 cos, c1 sorry not cos, c1 e power 2x plus c2 e power 3x. Verify this one, that is, write down auxiliary equation and from there you solve, you will get yc. Now next part, that is yp, I am doing here. So d square minus 5d plus 6 sine 3x. Alright, now wherever you have d square, immediately put minus a square. So here you will be getting minus c in place of, this is already in the form of phi of d square. Okay, so here in place of d square, what you need to put, minus a square means minus 9 minus 5d plus 6 sine 3x. So what you have here, 1 by minus 5d minus 3, that is sine 3x. Okay, so here minus you can take common, so basically 1 by 5d plus 3 you have. So the next step, see, your target is to make this d as d square. So what you will do, 5d minus 3, you just multiply this one numerator and denominator. Immediately a square minus b square formula you can apply here, correct? So what you have, see here, minus 5d minus 3, here in place of d square you need to put this minus 3 square, that is 25 into minus 9, here 9, that is sine 3x. So here the next step, minus 5d minus 3, here what you have, see, observe this thing carefully. So what you have, see, 9 you can take common, so that you will get minus 26. Okay, so sine 3x. Now here 5d, 1 by 9 into 26, 5d, d means derivative of sine 3x, that is 3 cos 3x minus 3 sine 3x. So you can take 3 common, so 3, 9 into 26, 5 cos 3x minus sine 3x. So immediately you will get 1 by 3 times here, so 78, 5 cos 3x minus sine 3x. So that is your YP, that is the YP you are getting. So general solution, it is given by general solution y is equals to c1 e power 2x plus c2 e power 3x plus 1 by 78, 5 cos 3x minus sine 3x. That will be the answer. Okay, so I think you got the idea how we can proceed when sine function or cos function they are involved. Okay, here sine it is involved, instead of sine, if cos is here, the same treatment you need to adopt. Now next we can take another problem which involve the next formula. That means, what are the formulas we are considering? See, sine, for sine we have applied this formula, sine or cos. Okay, now if polynomial function it is involved, so how we can proceed for those type of questions? So now we will consider a few problems related to this. So before going into this, we have few standard results. The results you should keep in mind, few important results. These results are basically from binomial theorem, the theorem where you have the standard form 1 plus x whole power n. Let me write this for you, 1 plus nx plus n into n minus 1 by 2 factorial, here you have x square, plus n into n minus 1 n minus 2 by 3 factorial x cube, and so on. Okay, so here if you particular case, if you investigate the particular case, that is x equals to 1 minus 1, okay, n equals to 1 minus 1, then these are the results, that is 1 plus x whole power minus 1, it is 1 minus x plus x square minus x cube plus so on, x power 4 and so on, that is 1 plus x whole power minus 2, 1 minus 2x plus 3x square minus 4x cube plus so on, then 1 minus x whole power minus 1, 1 plus x square plus x cube plus so on, then 1 minus x whole power minus 2, that is 1 plus 2x plus 3x square plus 4x cube and so on. These are the few standard formulas we have. Okay, and see, when I'm writing d of, suppose d of x square, that means what you are doing, d dx of x square, that is 2x. Okay, if I am writing d square of x square, means d dx of this 2x, that is 2. That is, if I am writing d cube of x square, that is d dx of 2, means 0. D power 4 of x square, that is 0, and so on. Okay, so this is a basic understanding you should keep in your mind when solving these questions. Okay, now see, first problem related to this area. Solve d square minus 2d plus 1 y is equals to x minus 1. Okay, x minus 1. So see the solution CF and YC, it is going to be C1 plus C2x e power x. This thing you need to verify. By writing auxiliary equation and then solving it. Okay, you'll get the YC. Now YP value, it is given by 1 by d square minus 2d plus 1 x minus 1. Okay, so this thing, say d square minus 2d plus 1, immediately you can observe this is nothing but d minus 1 whole square, and here you have x minus 1. So this thing can be written as 1 minus d whole square x minus 1. See, our target is what? Just go back to the previous slides. Our target is to convert into this form. That means basically this form, either 1 plus phi of d whole power n or 1 minus phi of d whole power n, 1 plus or 1 minus phi of d. Okay, so this is our target. So exactly this thing we are going to adopt here. See what you have, 1 minus phi of d, means phi of d means d here. So immediately what you have, 1 minus d whole power minus 2 x minus 1. So here 1 minus d means this formula you can apply, this third formula, 1 minus x whole power minus 1. So if you apply that formula, what you have, 1, see, this not exactly third formula, this is the fourth formula, 1 minus d whole power minus 2. This fourth formula you can apply. So 1 plus 2d plus 3d square plus 4d cube plus so on. This formula you can apply. So here you have x minus 1. Now what you need to do, you need to take this x minus 1 inside. So what you have, x minus 1 plus 2 times d of x minus 1 plus 3 times d square of x minus 1 plus 4 times d cube of x minus 1 and so on. So here x minus 1 plus 2 into derivative of this term, first derivative, so 1, and rest of the term will give you 0. Okay, so here you are getting this one as x plus 1. So this is your YP. So the general solution, it is y is equals to c1 plus c2x e power x plus 1. This is going to be the general solution. Okay, so this is how we can solve the question. Now another question I can take from this same domain. Here, suppose next question, suppose I am taking, write down, solve d square minus 4 y is equals to x square. solution. So yc, again this is for your homework purpose, you can try this. C1 is equals to C1 e power 2x, yc is equals to plus C2 e power minus 2x. You can verify this thing, verify. Okay, now yp it is given by 1 by d square minus 4 x square. Now target is what? You need to write in terms of 1 plus phi of d or 1 minus phi of d. So here you can take minus 4 minus 4 1 by 1 minus d square by 4 x square. So here immediately 1 by 4 minus 1, this thing you can write. So what you have in the next step, 1 minus d square by 4 whole power minus 1 x square. So in the next step, see here, the next step, 1 by 4 1 plus d square by 4 plus d power 4 by 16 plus so on x square. So if you just take this x square inside, what you have, x square plus d square by 4, it acts on x square, plus 1 by 16 d power 4, it acts on x square, plus so on, minus 1 by 4 x square plus 1 by 4 second derivative of x square. So immediately you will get 2. Immediately here you have 2 plus 0. Okay, so what you have, minus 1 by 4 x square plus 1 by 2. So if you just simplify this thing, I think you are going to get minus x square by 4 minus 1 by 8, that is y is equals to, final general solution, it is going to be C1 e power 2x plus C2 e power minus 2x minus x square by 4 minus 1 by 8. Okay, so I think you got the idea that you need to write this step properly, okay, this second step properly, and apply the respective formula of binomial theorem, and immediately you will get the answers. Okay, so this is how we can apply our third formula. Okay, now the next formula, where it is composition of exponential function with any function. Okay, so we are moving to our next slide. By that time you should practice this type of question, because these are very relevant, and if you practice this by applying inverse operator method, then immediately you can find the particular integral without going for undetermined coefficient or variation parameter if it is not mentioned in the exam. Now consider next question, and this question, it is application of this previous formula. See this last formula, this is our last formula, and we are going to see the application of this formula. Okay, now see, let me write this question. Solve d square minus 1 y is equal with e power x cos x. So solution, yc, again I am giving you yc, and you should verify this one, plus c2 e power minus x, verify this. Now yp, it is given by, what is yp, it is given by 1 by d square minus 1 e power x cos x. Okay, so what was that formula? Formula was like this, 1 by f of d particular integral e power ax, suppose in place of sign you can write any function, this is not specified here. Okay, so here v. Okay, so it was e power ax 1 by f of d plus a, now v. Okay, so this was our formula. So this formula we are going to apply here. All right, Now see this, e power ax, you can take it out, and here you should write d plus 1 square minus 1 cos x. Okay, so in the next step, e power x 1 by d square plus 2d plus 1 minus 1 cos x. Now here in this next step, what you have, e power x 1 by d square plus 2d cos x. So in place of d square, now you are going to apply which formula? In place of d square, you are going to put minus a square, and a is what here? 1. Okay, so in place of that d square, you are going to put this, so minus 1 plus 2d cos x. So what you have here, e power x 1 by 2d minus 1 cos x. Now see, this lower term you have only d, there is no term involving d square here, so you need to convert into d square involved term. So immediately what you do, 2d plus 1 multiply by 2d plus 1, so immediately here you get 4d square minus 1 cos x. Now again you can see d square is present, so in place of d square put minus a square, so e power x 2d plus 1 cos x. Here you have minus 4 minus 1, that is nothing but 1 by 5 e power x to derivative of cos x, that is minus sin x plus cos x. So in the next step, what you have, see, e power x by 5 2 sin x minus cos x. So this is going to be your yp. So you can observe here, basically you are applying this formula in the initial step, but later on you are applying the formula for sine function. Okay, that is replacing d square by minus a square. Okay, so this is how we can solve this type of question, and you should practice. So the final solution, that is general solution, it is given by, it is yc. What was yc? That is c1 e power x, c1 e power x plus c2 e power minus x plus e power x by 5 2 sin x minus cos x. Okay, so this is the final solution. Okay, so this is the method which is known as inverse operator method, and based on that you need to practice as many questions as you can. Okay, in the next lecture we'll be considering the application of first order differential equation we have studied in the initial I think 1 or 2 lecture, and the application of first and second order differential equation, homogeneous and non-homogeneous, we'll see through some physical problems. Okay, so wait for the next lecture. And here basically we have covered inverse operator method, 4 methods, 4 particular cases. So based on that you will get the lecture material and try to revise those things and solve the questions.